This is the 6th part of a tutorial series, in which I show you how to create mixed reality experiences for the Meta Quest 3. In this series, we use the Unity game engine, specifically utilizing Unity's native XR Interactive Toolkit. In the previous video tutorial, we looked at raycasts and spatial anchors. However, since that video, there has been a major update to the Unity OpenXR meta package, which is an integral part of our setup. Unity has now released version 2 of this package. Due to this update, I recently released a 2-part tutorial showing you how to upgrade our mixed reality project to OpenXR Meta 2. If you are following along with this tutorial series, I highly recommend that you first complete this upgrade tutorial, as OpenXR Meta 2 comes with new features and API changes. Anyhow, you'll find a link in the description. In this tutorial, we will explore a new feature available through OpenXR Meta 2 and AR Foundation 6. Specifically, we are going to take a look at bounding boxes. Bounding boxes on Meta Quest are similar to AR planes in that they create visual boundaries around real-world objects within the scene model. However, we get fully 3D boxes instead of just flat planes. During Meta Quest's scene setup, you can block out and label items of furniture in your real-world space. The furniture items whose bounding boxes can be visualized are listed here. Ensure that at least one of these items is defined in your scene setup before continuing with this tutorial. We will start implementing bounding boxes in our project shortly. However, if you would prefer to download the completed Unity project for this tutorial, it is available to Script Surveyor members of my Patreon community. Membership is available for a monthly subscription of just $3. You will find a link to the project download page in the description. Okay, let's get on with our project. I have prepared a couple of assets to help you complete this tutorial, including a prefab that you can use to visualize the bounding boxes. I have added these assets to the GitHub repository that accompanies this tutorial series. You will need to download the latest asset pack from there. Here's how to get it. Open a web browser and go to this repository on my GitHub page. Link in the description. To get the most recent assets, click on the latest release. Now click on quest3mrcourseassets.zip. The zip file should download to your PC. Go to your Downloads folder and extract the zip. Open the extracted folder and you will see that it contains 2 new assets, the AR Bounding Box Colored and AR Plane Colored AR6 Unity packages. We will want to import these into our Unity project. Go ahead and open the project now and make sure the scene we have been using throughout this series is also open. Let's import our packages. Go to the top menu bar and click Assets, Import Package, and then Custom Package. Find our Quest3mr Course Assets folder and open it. And now select the AR Bounding Box Colored Unity package and double-click it. An Import Unity package window should appear. Click the Import button. Repeat the procedure to import the AR Plane Colored AR6 package. Let's take a look at the assets that we have just imported. In the project view, select the Prefabs folder. Notice we have a new prefab called AR Bounding Box Colored. We will use this prefab to visually represent the bounding boxes present in the scene model. In fact, it works in a similar way to the AR Plane Colored prefab. Open AR Bounding Box Colored by double-clicking on it. You will see that we have 2 components attached to the root of the prefab. The first component is a script called AR Bounding Box. The script is part of AR Foundation, and this will be used to represent a single bounding box retrieved from the Quest's scene model. Before we move on to the next script component, let's quickly take a look at what else is contained within this prefab. If you check the hierarchy view, you will notice that the prefab has a cube child object. This cube is used to render the bounding box. Let's take a quick look at its components. It has a mesh renderer and a standard URP material, which is set to transparent. I've also added a box collider because I want physics objects to bounce off these bounding boxes. Okay, let's go back to the root of the prefab. Let us now take a look at the AR Bounding Box Colorizer script component. Double-click on the script to open it in Visual Studio or Alternative Code Editor. This code does 2 fairly simple things. Firstly, it sets the color of the child cube according to the bounding box's assigned classification. Remember, the bounding box can be classified as couch, table, bed, etc. This is done in the Update Box Color function, which is called from awake. Secondly, it adjusts the dimensions of the child cube to match the dimensions of the AR bounding box. Okay, now return to the Unity editor. A quick note. When we imported those Unity packages earlier, we included a package called AR Plane Colored AR6. This package updates the AR Plane Colorizer script, a component of the AR Plane Colored prefab that we have been using for our plane visualization. Let's see what has changed in this script. One subtle change is moving the call to the Update Plane Color function from the Start method to Awake. The reason for this change is that I found switching the plane visualization off immediately upon initializing the AR planes resulted in some of the planes remaining visible. Moving the Update Plane Color function from Start to Awake resolved this issue. The other notable change is the use of the new plane classifications enum, instead of the now obsolete plane classification. Anyway, let's get back to the task at hand. Let's start implementing our bounding box visualization. Return to the Unity editor. Go back to the root of our scene. In the Project view, select the Prefabs folder. And in the Hierarchy view, select the XR origin. Now go to the inspector, and at the bottom click the Add Component button. Add the AR Bounding Box Manager. For the sake of neatness, I want to move the AR Bounding Box Manager above the Scene Controller. Click on the three-dot menu in the top right corner of the AR Bounding Box Manager and select Move Up. We need to set the Bounding Box prefab variable on the AR Bounding Box Manager. Drag the AR Bounding Box Colored prefab onto this empty slot. In order to access the bounding boxes in your Quest's spatial data, we need to activate the Bounding Box feature in the MetaQuest plugin settings. Go to the top menu bar and click Edit, and then Project Settings. In the Project Settings sidebar, under XR Plugin Management, you should see an Open XR option. Select it. Make sure the Android tab is selected. Under Open XR Feature Groups, you should see a number of checkboxes. Make sure MetaQuest Bounding Boxes is ticked. You can now close Project Settings. Alright, that's pretty much everything we need to do in the Unity editor. Next, we're going to modify our SceneController Script so our app can cycle through the bounding box and plane visualizations. Double-click the SceneController Script to open it. Okay, the first thing we are going to do is create a variable to reference our AR Bounding Box Manager. Go to where we declare our AR Manager variables and add this line. Go to the line where we declare the isVisible variable. Delete it and replace it with this visualization mode variable instead. As the variable name suggests, this will be used to cycle through 3 AR visualization modes, rendering either AR planes, bounding boxes, or nothing at all. Okay, now scroll down to the Start function. We want to get a reference to the AR Bounding Box Manager, and we want to assign it to our _Bounding Box Manager variable. Enter the following lines. And notice that at the bottom of the function we subscribe to several events. We want to subscribe to the Bounding Box Manager's Trackables Changed event. Insert this line. We need to create an OnBoxesChanged event handler. To keep things tidy, I want to put this immediately below the OnPlanesChanged event handler. So let's scroll down and find it. Here it is. Let's insert an OnBoxesChanged event handler below it. The event handler is empty for now, as there are a few other changes that we need to make before adding code to this function. First of all, delete the entire printPlaneLabel function. Replace it with this printTrackableInfo function. It essentially does the same thing as the previous function, in that it prints some debug info on the AR object. However, it now works for both planes and bounding boxes. Now go to the OnPlanesChanged event handler and replace the call to printPlaneLabel with printTrackableInfo. Finally, let's fill out the OnBoxesChanged event handler with some code. Notice that the code is almost the same as in OnPlanesChanged. The only real difference is that we are passing a bounding box into the printTrackableInfo function instead of a plane. Anyway, since we are focusing on bounding boxes in this tutorial, let's comment out the debug logs in the OnPlanesChanged event handler, including printTrackableInfo. Now scroll up and find the OnTogglePlanesAction event handler. Delete all the code inside of the function. Every time the user presses the A button on the right-hand controller, we are going to cycle through 3 visualization modes. Mode 0 will not display any debug visuals. Mode 1 will render our AR planes, and Mode 2 will render any AR bounding boxes in our scene model. To cycle the visualization mode, type the following line. Next, we will create a function called setVisualization to set up the visualization after switching the mode. We will add code to this function shortly, but first, I want to add a call to this function at the end of onTogglePlanes action. Note that we are passing the visualization mode variable to the setVisualization function. Before we can complete our setVisualization function, we need to create 3 more supporting functions. The first we will call setPlanesVisibility. The function will set the visibility of each AR plane in our scene model. It takes a single Boolean argument, which tells the function to either hide or show the planes. The second function will be similar to the first and will be called setBoundingBoxesVisibility. This will be used to switch the visibility of AR bounding boxes on and off. The third function will be called setTrackableAlpha. This will be used by the previous 2 functions to set the alpha and thereby the visibility of either a plane or bounding box material. Anyway, things will become clearer as we implement these functions. Let us then add the code for setPlanesVisibility. It's pretty straightforward. First, we set the alpha values for both the mesh and line materials that render the plane, depending on whether we want the AR planes to be visible or not. Next, we iterate through each plane, and through the setTrackableAlpha function, we apply our alpha values to their respective materials. Of course, we have yet to implement setTrackableAlpha. Now let's add the code for setBoundingBoxesVisibility. You can see that the code is almost identical to setPlanesVisibility. The only difference is that we are iterating through a collection of bounding boxes rather than planes. Finally, let's implement the setTrackableAlpha function. As you can see, the function takes an AR trackable object as a parameter. AR trackable is the base class of both AR bounding box and AR plane, so we can pass either of these into the function. The last 2 function parameters are the alpha values for the mesh and line materials. The first step in the function is to get a reference to the mesh renderer component. Using the mesh renderer, we access the mesh's material and, ultimately, its color. We then modify the alpha value of this color based on whether the material should be visible or not. Next, we get a reference to the trackable object's line renderer component. If our trackable has a line renderer, we modify the alpha of the line color similarly to the mesh material. Note that each line has both a start and end color, and we adjust the alpha values for both. Okay, now for a bit of tidying up. Scroll down until you can see the whole of the setPlaneAlpha function. This function is no longer needed, so let's select and then delete the whole thing. Now let's scroll back up to the setVisualization function. Add the following code. The function is simple. It just sets the visibility of both the AR planes and AR bounding boxes depending on the specified visualization mode. Okay, before we finish up, I want to add a call to setVisualization in a couple of other event handlers, besides onTogglePlanes action. Scroll down to the onPlanesChanged event handler. Insert a call to the setVisibility function just below the debug log statements. Now, go to the onBoxesChanged event handler. Once again, insert a call to setVisibility immediately below the debug log statement. These 2 function calls will ensure that the correct visualization is applied immediately upon initialization of the AR planes and AR bounding boxes. Alright, there's one last thing that we need to do. Scroll down to the onDestroy function. We need to unsubscribe from the Bounding Box Manager's Trackables Changed event. Insert this line. Okay, we have finished with the SceneController Script. Save your work and return to the Unity editor. Make sure your scene is saved, then go to Build Settings. Ensure your Quest is connected and launch a new build. Inside the app, try pressing the right-hand controller's A button. It should cycle through the visualization modes, including AR bounding boxes. The bounding boxes have collider components, so they should also interact with any physics objects, deflecting them as expected. And that brings us to the end of this tutorial. If you found it useful, please like and subscribe. Thanks for watching, and until next time, goodbye and happy questing.